are going to look at solving absolute value equations. So it's similar to what we've been doing, but it is going to look a little different because we're going to end up setting our equation equal to two different numbers. So our first steps we're going to follow, we are going to, one, make sure that the absolute value expression is isolated. Just like we isolate our variable, we are going to have to isolate an entire absolute value expression. Our second step, number two, is to set the inside of the absolute value, so whatever expression is inside the absolute value, equal to both the positive and negative number from the other side of the equation. And the reason we do this is because the absolute value makes a number positive. So we can plug a negative number into an absolute value sign, and we're gonna get a positive number. So that means that we can have more than one solution, right? It's not necessarily an infinite amount of solutions, but it means that we could have 1, 2, or maybe even 3 numbers that we can plug in and make this equation true. Our third step is to just solve both equations. So we're gonna end up solving 2 different equations per problem. And then our final step, number 4, is to write your answer as a solution set. And we use brackets to show what are the different solutions that we can have for this equation. So the first examples are pretty straightforward. It just says the absolute value of x is equal to 2. So we're going to isolate our absolute value, which is just x, and we're going to set that equal to positive 2, which is what we have. But then we're also going to set that equal to negative 2, because if we plug in negative 2, the absolute value of negative 2 is 2. So our final answer for number 1 would just be x equals, then we do our brackets, and we have negative 2, 2, close the brackets, and that is our final answer. So that is what I'm going to box. So very simple when the variable is by itself. So it's going to be the same thing for n, or for number 2. The absolute value of n equals 14. That means that we isolate it, and we drop the absolute value signs when we isolate it. n equals 14. n equals negative 14, because like what we said in step number 2, we have to set it equal to both the positive and negative number from the other side. So our solution is n equals 14 and 14. Notice that we always have the negative number first. It's because we write our solution set going from the smallest number on the left to the biggest number. So you should always have your negative number first and then your positive on the right, since your negative numbers are smaller than your positive numbers. All right, number 3 is where you're going to start to see how we solve these when we have more than just the variable and the absolute value bracket. So inside the absolute value, we have 5z. So I'm going to isolate that, and I'm going to set it equal to 40, like what we have. But then I also have to set it equal to negative 40 over here. So I'm going to start with 5z equals 40. This is just a one-step equation. You guys are pros at solving these. So I'm going to multiply by my reciprocal. I get z equals, multiply by 1 over 5 here, and z equals 8. Well, when I do this on the other side and I multiply by 1/5, cancels out, we get z, multiply by 1/5, going into the next box, I get z equals negative 8. So that means if I plug in 8 into the solution or I plug in negative 8 into the solution, either way I'm going to get 40, because 5 times 8 is 40, the absolute value of 40 is 40, 5 times negative 8 is negative 40, but the absolute value of negative 40 is 40. So both of these make this equation true. So our solution is going to be z equals negative 8 and 8. And that would be your final answer for number 3. I'm going to skip number 4 for now. You guys are going to go back and do that, and I'm going to show you what we do with number 5. So number 5, we have the absolute value of d plus 1 equals 8. So I'm going to isolate what I have inside the absolute value brackets and set it equal to positive 8 and then negative 8. So I have d plus 1 equals 8, and I have d plus 1 equals negative 8. I'm going to go ahead and solve d plus 1 equals 8, add negative 1, add negative 1, d equals 7. Same thing on the right side, I'm going to add negative 1, add negative 1. But over here, d plus negative 8 plus negative 1 is going to equal negative 9. So that means that my solution set for number 5 is d equals negative 9 and 7. I'm going to close my brackets. Box my answer. All right, I'm going to skip number 6 as well, and I'll show you guys what to do for number 7. So for number 7, we have the absolute value of 4n plus 2 equals 34. Again, just like what we've been doing, I'm going to isolate our absolute value. So I'm gonna have 4n plus 2 equals 34, and I'm gonna have 4n plus 2 equals negative 34. We're always taking what it's equal to and using the positive and then the negative. So now we have a two-step equation. You guys are also pros at these, so we're gonna solve like we always do, plus negative 2 plus negative 2, 4n equals 32, multiply by our reciprocal, and n equals 8 for using positive 34. Then when we solve with negative 34, add negative 2, add negative 2, we have 4n equals negative 36, multiply by the reciprocal, and n equals negative 9. So our solution for number 7, I'm going to write it over here to the left where there's a little bit more room, is n is equal to negative 9, again always have your smaller number on the left, and then positive 8. And that is my solution there. Alright, I'm going to skip number 8 as well. I'm going to have you guys go back and do the ones that we did not do. Looking on the next page, it says, what if there is stuff outside the absolute value bars? Well, if there's stuff outside of the absolute value bars, that means that we have to isolate it first, right? So just like we always do, we're always trying to isolate our variable. We have to isolate the, I'm going to abbreviate it to A, B, the absolute value, right? Think of it as a variable that we have to get by itself. So if I'm looking at number 9, I have the absolute value of C plus 2 equals 12. I need to get rid of that 2 so that I have just the absolute value on one side of the equal sign. So I'm going to add negative 2, add negative 2, and now I have the absolute, ooh, messed that one up, 1 second. All right, I have the absolute value of C is equal to 10. Well, now that my absolute value is isolated, I can set C equal to 10, and then C equal to the opposite, which is negative 10. I don't have to solve for anything, we're done. So C is equal to negative 10 and 10. That is my solution set. So if I were to plug those numbers into the absolute value, I would get 12 for the original equation. So the absolute value of 10 is 10 plus 2 is 12. The absolute value of negative 10 is 10, 10 plus 2 is 12. So we get the correct answer no matter which number we plug in. All right, let's take a look at number 11. I'm going to skip number 10 since it's similar. So I have 6 times the absolute value of x equals 24. Well, we know that if we have to get rid of something that's being multiplied, we're going to multiply by the reciprocal. So I'm going to multiply this whole expression right here by the reciprocal of 6. I'm going to leave the absolute value alone. I'm just multiplying by 1 over 6. This is going to cancel the 6 out, so that all I have left is the absolute value of x. I'm going to do the same thing on the right, 1 over 6, and 24 times 1/6 is equal to 4. So now I have the absolute value of x is equal to 4, which means that we're going to set that equal to positive 4 and negative 4. So x equals 4, x equals negative 4. There's nothing for us to solve. So our solution set is negative 4 and 4. And that would be our final answer for number 11. All right, so let's take a look at number 13. We've done two-step equations similar to this, right? So I have to get rid of that denominator, right? That denominator is blocking me. So what's inside of my absolute value is 2w minus 4, and that's what I need to isolate. So in order for me to get rid of that 6, I need to multiply by 6 over 1, and that's going to cross cancel to leave me just 2w minus 4 inside the absolute value signs. Well, whatever I do to one side, I do to the other. I multiply by 6 over here, so this is going to be set to 18. So that means I'm now going to set 2w minus 4 equal to 18, and 2w minus 4 equal to negative 18. So I'm just going to do that right here. All right, and now I just need to solve both equations. So add 4, w equals 22. Multiply by the reciprocal, and write the small w equals 11. All right, same thing over here. Now I'm going to add 4, but now I have negative 18 plus 4, so that's going to be 2w equals negative 14. Multiply by the reciprocal, W equals -7. So that means that our solution set, I'm gonna write this to the left, is W equals -7 and 11. Again, always write smallest to biggest, right? So W equals -7 and 11. So that means that either of those numbers that we plug into the original equation, the absolute value of 2W minus 4 divided by 6 equals 3, both of those numbers will make that equation true. All right, let's take a look at number 14, and then we'll move on to the bottom and look at 17 and 18. So for number 14, we have two different things going on that we need to get rid of in order for us to isolate our absolute value. So just like if this was a two-step equation and you had negative 10h plus -3 equals -83 or some equation like that, we always want to get rid of what's being added to the variable first. So that means that I need to add this +3 to cancel out the -3 and add +3. This is now going to give me -10 times the absolute value of h plus 5 equals -80. Well, to get rid of something that's being multiplied, we have to multiply by the reciprocal. So I'm going to multiply by 1 over -10 to both sides. So I'm going to set this whole thing over 1, right, because it's a big grouping. So then I'm going to multiply by 1 over -10, running into the other problem. Just the -10s are going to cross cancel. So that leaves me with the absolute value of h plus 5, right? And then I have to do the same thing to the other side. So 1 over -10. And that means that the absolute value of h plus 5 is equal to +8, since -80 times 1 over -10 is +8. Now that my absolute value sign is isolated, I'm going to set it equal to both +8 and -8. Oh, negative. Okay, so add -5, that's 0, add -5, and h equals 3. Add -5, that's 0, add -5, and -8 plus -5 would be -13. So h equals -13. So that means that my final solution set for number 14, I'm just going to write this in the top right since there's a little bit of room here, is h equals -13 and 3. All right. So that would be my final answer for number 14. Okay, we are going to skip down to number 17 and number 18. So these are some special cases. It says solve the equations below and explain their solution. If you look at number 17, it says the absolute value of x equals -6. Well, our solution for number 17 is going to be null, right? There is no number that you can plug into that absolute value sign and get -6, because the absolute value of a number cannot equal a negative number, right? Once we isolate it, it has to be positive. That is what we define as absolute value, right? A number's distance from 0, it is a positive number. If we were to solve for number 18 and we isolated our absolute value, I'm going to write this as 1 over 1 and multiply by 1 over -3. That cross cancels. Same thing over here. 1 over -3. My absolute value of 2x plus 1 is equal to -7. Again, once the absolute value is isolated, it cannot equal a negative number, right? So again, we do not have a solution for number 18. This will be another null. So the reason for this is the absolute value cannot equal a negative number once isolated. So just like we talked about when we were looking at different types of solution, null means that there is no number that we can plug into that solution to make it true, and it's the same thing with these two cases. There is not a single number that we can plug into our absolute value sign and end up with a negative number. It is just not possible, so our solution is null. I'm going to stop here. What I want you guys to do is go back and complete all of the problems that I did not do. You can go ahead and hit pause so that you can work on them on your own. I am going to keep going back without talking and solve them so that you guys can check your work. So you can go ahead and hit pause now or stop now, do the work on your own, and then when you hit play, you can go back and see how I solved the problems to see how you're supposed to do it.